Hello and welcome back to my channel. In this tutorial, I'm going to talk about gradient boosting and how to classify data using gradient boosting methods with Scikit-learn. Gradient boosting is a powerful ensemble learning technique used for classification and regression tasks. Its effectiveness and flexibility make gradient boosting suitable for implementation in various domains in machine learning. In this tutorial, we'll briefly learn about gradient boosting classification using Scikit-learn machine learning library in Python. This tutorial covers introduction to gradient boosting, preparing data, defining the model and training, hyperparameters, making predictions and evaluating the model, and the conclusion. Let's get started. Gradient boosting is an ensemble learning technique that constructs a sequence of weak learners, typically decision trees, in a sequential manner. Each learner in the sequence aims to correct the mistakes made by the previous one. It optimizes the loss function directly using gradient descent, making it highly effective for handling complex datasets and producing accurate predictions. Gradient boosting includes the following components for training the model and predicting the data. The first is initialization. Gradient boosting starts with an initial prediction, often the mean value for regression tasks or the log odds for classification tasks. Second is sequential training. It sequentially trains a series of weak learners, usually decision trees, each attempting to correct the errors made by the combination of all previous learners. The third one is gradient descent. It optimizes the loss function directly using gradient descent. It minimizes the loss by adding weak learners that minimize the gradient of the loss function with respect to the ensemble's prediction. Next is at each iteration, a weak learner is trained on the residuals, the difference between the current prediction and the actual values. This weak learner is fitted to the negative gradient of the loss function with respect to the current predictions to reduce the residual errors. The prediction from all weak learners are combined to obtain the final ensemble prediction. Each learner contributes a weighted prediction to the ensemble. Next is regularization. To prevent overfitting, gradient boosting applies regularization techniques like tree depth limit, shrinkage or learning rate, and sampling of training instances. Gradient boosting can be applied for classification loss function like a binary cross entropy or multinomial deviance. Finally, gradient boosting continues adding weak learners until a specified stopping criterion is met, such as reaching a maximum number of iterations. That's brief about the explanation of the gradient boosting. Now let's start writing a code to implement classification with gradient boosting. We'll begin by loading the necessary libraries for this tutorial. Here we use datasets, model selection, ensemble, and metrics modules of Scikit-learn. Next, we create a synthetic classification dataset generated using the make classification function from Scikit-learn. The dataset contains 1000 samples with 5 input features and 4 classes. We can check the dataset and it looks like this. Then we split data into train and the test parts. Here we use 20% of data as a test data. We initialize gradient boosting classifier using the gradient boosting classifier class from Scikit-learn, where we specify hyperparameters such as the number of trees, learning rate, and the maximum depth. We proceed to train the gradient boosting classifier on the training data by calling the fit method. Here we define the gradient boosting classifier with estimator number 100 and learning rate is 1.1 and max depth is 3. And we fit the model with trained data. Hyperparameters are parameters that are set before the learning process begins. They control the behavior of the learning algorithm and influence the performance of the model. By adjusting these hyperparameters, you can fine-tune the performance of the gradient boosting model to achieve better accuracy and generalization on unseen data. However, finding the optimal combination of hyperparameters often requires experimentation and tuning using techniques like a grid search or random search. Here, an estimator specifies the number of the weak learners, decision trees in this case. that will be combined to form the final ensemble. Increasing the number of estimators may improve the model's performance, but it also increases the computational costs. Learning rate determines the step size at which the gradient descent optimization procedure adjusts the weights of the weak learners. A lower learning rate makes the model more robust to overfitting, but may require more iterations to converge. Maximum depth specifies the maximum depth of each decision tree in the ensemble. It controls the complexity of the individual trees and helps prevent overfitting. Next is making prediction and evaluating the model. Using the gradient classifier, we proceed to make predictions on the testing data by calling the predict method. Then we calculate the accuracy of the model by comparing the predicted labels with the true labels from the testing set. To achieve this, we use the accuracy score and classification report functions from Scikit-learn. These functions provide the metrics such as precision, recall, and F1 score, enabling to comprehensive evaluation of the classification performance. Here is the prediction on the test set. Then we calculate the accuracy of the model by using accuracy score and the classification reports. The result appears as follows. The accuracy is 84%. Precision, recall, F1 score, and support is included here. That's it for this tutorial. In this tutorial, we briefly learned the gradient boosting and how to implement classification by using this method with Scikit-learn library. Gradient boosting is a powerful ensemble learning technique that can be used for classification and regression tasks. The full source code is listed here. I'll put the link to source code in description. If you like this video, please subscribe my channel, hit like button. Thank you for watching and see you next time.